f of g, or f of h, and we're saying g plus h. So what is my g function?
X minus 3.
X minus 3 plus the h function. 2x plus 4. Okay? So we're going to write it out, and then you need to combine like terms. Okay? And then it will be finished. So what can we combine? 1 into 2 is going to give me 3x. And then I got a negative 3 and a 4 is going to give me a positive 1. Okay, so that's adding the functions, okay? The next one on here is about subtracting the functions, okay? And you need to say this g, okay, g minus f in parentheses, okay? That's going to be your first step. Your second step is going to be to distribute or to multiply everything by negative 1, okay, because there's really a negative 1 there, okay, and then lastly, combine like terms. Okay, so my g is going to be x squared plus 5x minus my f, which is 3x plus 2. Okay, so we wrote it out just like it said, and then the next step says distribute or multiply everything by negative 1. Okay, so, and I'm just gonna do like this, okay, so you're gonna do, okay, like that. You're gonna multiply each piece by negative 1. So you're gonna get x squared plus 5x, okay, negative 1 times negative, or 3 is gonna be 3x, negative 1 times 2 is gonna be negative 2. Okay, so then we can go ahead and combine like terms. What can we combine? The 5 and the 3. Okay, so we're going to get x squared, and that's going to give me a plus 2x minus 2. Okay, the next section on here is the multiplication one, okay? So that one is going to look like, and you might just have to draw yourself a very detailed, good graph. It's going to look like, and I don't even know how to, okay, you're going to draw your two parentheses. Okay, you're going to take this first piece and multiply it by that first piece. Okay, and then you're going to take this first piece and multiply it by the second piece. Okay, and then you have to take the second piece of the first one and multiply it by the first one, and then the second piece and multiply it by the second one. Okay, so you're going to be multiplying 4 times. Now, and this one is kind of a bad example because there's only one, but essentially, whatever's in your first parenthesis needs to get multiplied by each piece in the second parenthesis. Okay, and the reason I said this one is kind of a bad one, and so is 6, is because this one has 3 pieces, and this one only has 1 piece in one of them. Whereas most of the time you're going to have them where it has 2 and 2, 2 and 2. Okay, so my first one is going to be n3 plus 3n times negative 4n. Okay, so we're going to take this first one and you're going to multiply it by everything in the second one. And in the second one, there's only one thing, so that one's good. Okay, so you're going to say 1 times negative 4 is going to be negative 4. How many n's do we have from here to here? 4. So we're going to say n4. Okay. And then you're going to take this one and you're going to multiply it by this one. Okay, well, 3 times negative 4 is gonna be negative 12. And then we count our n's. Well, he's got 1 and he's got 1, so it's gonna be n2. Okay, and then your next step would typically be to combine. Okay, and in this case, is there anything we can combine?
No.
No, so this problem is done. I can't combine these two because one has a 4 for an exponent and one has a 2. Okay, the next one on here is about dividing. Okay, so it's really just the top one, and then you put the bottom one where it goes. Okay, so this in this case is going to be g over h. Okay, my g function is n minus 4 over n plus 5. And so this is done. Okay, the next section on here is a composition function. So you're gonna, and you might have to tweak what this is saying, but you're gonna start from the number, which is this, and then go to the left, okay? Go to the left function, okay? Which the left function is gonna be h first, okay? So it's gonna look like h. Our h function is x squared minus 2x, okay? And everywhere there's an x, I'm plugging in a 6. So it's going to look like 6 squared minus 2 times 6. Okay, and just type this on your calculator. 24. Okay, so then you're going to take the 24, and you're going to plug in to the other function. Okay, which happens to be the g function. So g is x minus 3, and instead of the x, I'm plugging in 24. So 24 minus 3
21.
is going to be 21. Okay, now, I'm not saying you have to write notes for everything, but if you know you suck at these, then probably write these notes. Okay, if you suck at the next section, then write those notes. Okay, or write them all. I don't really care. Okay, and then you guys need to be using your time wisely during success, during if you have missed assignments, what have you. If you need some help, come see me. Mr. Hisson's okay at math. Simons is pretty good. Okay, or maybe you're a success teacher. Okay, so please get some help if you need it. Okay. The next section on here is write it in radical form, okay? So both of these kind of look similar in the sense of this is radical form has a radical, okay? Exponent form has an exponent. So we get our number, and this one you're gonna have a number, okay? And then what goes where? The 10 definitely goes inside the radical. Which one goes in?
The 5.
The 5. Okay, so it's going to be 5 over 4. Okay, so essentially you're taking the top number goes on the inside, and the bottom number goes on the outside right here. Okay, when we write it in exponential form, this is going to be the inside number over the outside number. Okay, so if we're looking at this one, obviously our big number is going to be what? 7. What is on the inside?
2. No, wait, out 0.
What's on the inside? A 1. Okay, there's really a 1 here and a 2 here. So it's going to be 1 over 2. Okay, 15 is about simplifying radicals. Okay, so you need some factors of 63. What are some factors of 63?
3 and 21.
3 and 21. 21.
3 and 7.
3 and 7. Okay, what's our numbers that we can circle, group, etc.?
3.
Well, our numbers in general. What numbers are we allowed to circle, group?
Oh, 2, 3, 5, 7.
2, 3, 5, 7. Okay, those are all prime numbers. Okay, and it does keep going. There's other numbers after this, but you would never have them, okay? So in this case, what is our group number? 2. So who can go? The group of 3s, and they're going to go on the outside. And then the 7 is going to go back on the inside. Okay, how many X's do I have? 1. So can he go? No, so put him back. Okay, and then I got 2 Y's.
That goes in the outside.
Yep, one group can go on the outside. Okay, what if I had 2 Y's here? What's it going to look like?
Y2.
Y2. What if I had 2 3s here?
You multiply them.
You multiply them and it'd be 9. Okay, so if you have extra stuff, they're going to get multiplied. Okay, and so this is our answer. It's completed and finished. Don't forget, like 16, your answer should look like this with a baby 3 there. Okay, now I don't know what as far as goes on the inside and outside. That's for you to figure out, but you should have a baby 3. You're pulling in groups of 3. Okay. $17.
You add a -1.
You definitely are going to add a -1. Okay, so the steps are going to look like this. You need to simplify the radical. Okay, so it should look like 2, 3, 5, 7 on the inside, something like that. Okay. Okay, and then if the insides are the same, then you can add the outside. Okay, if they're not, that means you cannot combine them. Okay, so if the insides are the same, you can add the outsides. Okay, so you kind of got to do these just in pieces. What are some factors of 18?
9 and 2.
9 and 2, 3 and 3. Okay, and then we're going to drop this -1 down. Okay, so who can go? A set of 3. So he's going to go on the outside. Who's going to cannot go?
2.
The 2 on the inside. Okay, moving to this second radical, we can drop this plus and this 2 down. Okay, what are some factors of 8? 2 and 4. 2 and 2. So who can go?
2.
A set of 2s. Who can't go?
A set of 2.
Good. Okay, now what do you do with the outsides? Multiply them. So we're going to get -3 square root 2 plus 4 square root 2. Okay, now if the insides are the same, add the outsides. So are our insides the same?
Yeah.
Yeah, so we can put -3 and the 4 together to give me 1 square root of 2. Okay, so realistically, it's just like simplifying radicals the way you normally would. Once you get them the same, then you can add them or subtract them. Okay, but other than that, you're just going through the steps and reducing that radical. Okay, it looks crazy. Okay, but that's the gist of it. So, can 5 be simplified? No. Okay, but there is a 1 here, so we can go ahead and write this one down. -1 square root of 5. Okay, and we can drop this negative and this 2 down. Okay, what about 20? What are some factors of 20?
2 and 10.
2 and 10,
2 and 10.
2 and 5. So what is that radical going to become? 2 square root of 5. Okay, so a group of 2's can go, and then we got square root of 5. What are these 2's going to do? Multiply. So you're going to get -1 square root of 5 minus 4 square root of 5. Are they the same on the inside?
Yeah.
Yes, so we can combine the outside. So you're going to get -5 square root of 5. Okay, 21, multiplying radicals. Okay, so you're going to multiply the insides. If you need to, multiply the outsides. And then you're going to simplify. I wrote simply, but it's fine. Okay, so we're going to multiply the inside. So what is 6 times 8?
48.
48. Okay, are there outsides to multiply?
No.
No, and so we're going to simplify this. Okay, what are some factors of 48?
224.
2, 24,
212.
2, 12,
26.
2, 6, 2, 3. Who can go?
2 sets.
2 groups of 2's, 1 and 2. So you get 2, 2, square root of 3. What do you do with those 2 2's? Yeah, so it's going to look like 4 square root of 3. Okay, using our instructions, it says multiply the insides, multiply the outsides. So if we multiply the outsides, what is -3 times -3?
Positive 9.
+9, square root, and then we multiply the insides. 6 times 3,
18.
18. Okay, and then it says simplify. Okay, so what are some factors of 18? 2, 9, 3, 3. So who can go?
1 set of 3.
A set of 3's, and the 2 goes back on the inside. What do you do with that 9 and 3? Multiply, and you're going to get 27 square root 2. We're almost done. We got 4 left. Okay, for the dividing radicals. Okay, okay, you can put them underneath. I don't know how to say it, but essentially this is what you're doing. You're putting them both under here, under the same radical, okay? Okay, putting them both under the same radical. You're going to reduce the fraction. And then simplify. Some things are just hard for me to write directions, okay? But, so, we can put these under the same radical. So it's going to look like 9 over 25, okay? And then on your calculator, you can hit the fraction button. What does 9 over 25 simplify to? Huh?
Nine.
Nothing. Okay, so if it doesn't do that, then you can look at them separately, but it's 10 times easier every time to put them underneath the same radical and check. Okay, so what, the fraction doesn't reduce, so now it says, well, to simplify. What is the square root of 9? 3. A square root of 25? 5. Yeah, you can do them together or separately. Most of the time, it's gonna work better to do it this way, which is why I say check it every time. Check it underneath and see if that works. Okay, so 27, you work the same method. So you can kind of separate these two and say 3/5 is this first part, okay? And then this second part, you're gonna say square root of 12 over 25. Okay, does 12 over 25 simplify? To what?
It's 12. It'll simplify.
It don't simplify, which means you're gonna have to do them separate. So what is a square root of 12 simplify to? It does. What are some factors of 12?
2 and 6.
2 and 6, 2 and 3. So what is that radical going to become? 2 square root of 3. Okay, so we already have this 3 on the top that they gave us. Okay, and then we know that this radical is going to become 2 square root of 3.
Wait, why you put it there? 3 and 2?
Because this 3 that they gave us,
Oh.
and then this 2, and then that 3 left over. Okay, and then we have this 5 that they gave us, right? And then what does 25 simplify to? Just 5. Okay, and there's nothing left underneath that radical. Okay, so, and if you don't know, do the longer method, okay, and it's gonna give you 5 and 5, and you circle them and put them on the outside. Okay, so on here, what is, we're gonna get 6 square root of 3 over 25. Okay, the division ones are probably the hardest because there's not like an exact set of steps, okay? Check it, obviously if it don't work, then do it the longer way and simplify them separately, okay? And put the pieces where they go. Okay, and then last but not least, simplifying or solving radical equations. Hey, we did this yesterday, okay? So the whole goal here is to move everything away from radical, okay? So we cannot have something here, and we cannot have anything here. This is not allowed. Those have to be moved away first, okay? So anything that's not directly underneath the house, okay? See, like you can see the 4 is underneath the house, but if there was like a +1, the house doesn't extend to that part. So you need to do that first, and then you're gonna square both sides. So an exponent of 2. And then solve for x. Okay, so is 29, is the radical by itself? Yes, so we're gonna go ahead and square both sides. Okay, 1 squared is 1. And then this side, that's going to cancel, so you got n minus 4. Okay, and then what do we do?
Plus 4.
Plus 4. So we get 5 equals n, and that one is done. Okay, 31. What's going to get done first? Add 2 to both sides. Okay, so see how it's like hanging outside the radical. That means that needs moved first. Okay, so we're going to get square root of 32x plus 4 equals 10. Okay, and then what can we do?
Square both sides.
Yeah, we're gonna square both sides. So we're gonna say squared and squared. Okay, so on this side, you're gonna have 32x plus 4 equals what? What's 10 squared? 100. Okay, and then what? Minus 4, minus 4. 32x equals what? 96. Then what?
Divide by 32.
Divide by 32.
3.
And we're gonna get x equals 3.